Number 8, scatter plot. Right? The scatter plot means that we got some dots scattered all around. Right? It's data. And what they want us to do is figure out what the correlation is. So does it have a negative, positive correlation? Right? Is it linear? Okay? How linear is it? Right? That's what correlation is. The R value tells you how linear it is. Is it really linear? Like if it's perfectly linear, the R value is 1, right? Or negative 1, right? Depending if it's a negative or positive slope. Okay? If it's not linear at all, like somebody took a gun and shot it with the bird shot, right? Just all spread out, but it's very circular. Okay? That's like a 0. Okay? So this, I'm going to take a color that's light, just so I can get a rough understanding. So I'm going to cut these points in half. So I've got 1, 2, 3, 4, 5, 6 of these points right here, 7 points, and then 1, 2, 3, 4, 5, 6, 7 points. So if I cut this in half like this, right? That's a pretty good, it's not perfect, but it's pretty good. In fact, these would pull this line up a little bit, right? Pull it up a little bit. But I'm not using these points. Is that clear? I am not using these points at all. Not at all. I'm just using them to guide me. I'm not connecting these points. Does that make sense? I'm using them to guide me. This line tells me what kind of correlation I have. What is the correlation? Is negative. Okay? It has a negative correlation. Okay? And that's number 8 is the correlation and the R value. The R value is also, well, I know it's negative, right? How negative? Does it look like I took a gun and shot it with the bird shot? No. It looks like I might have taken darts and tried to make a line, right? I mean, I was pretty precise, but not perfect, right? Okay? So, I have points that I'm trying to make, okay? And so, what I want to do here is say how linear it is. Now remember, when it's really wide, right? Really wide, that was a 0.7, right? In this case, negative 0.7, right? Or even, this might even be a little bit more towards a 6 because of this roundness to it. Okay? Now, as it gets tighter, we get to a 0.8, and really tight, 0.9. You see what I mean? So, 0.8, 0.9. What's this one? What's it look like? 0.8, yeah, I would agree. It's not quite as wide as a 7, right? But it's not as tight as a 9. 0.8. Now it's negative, so it's negative 0.8. Okay? Alright? Now, with that said, I can do number 10. Or number 9. And number 9 is doing the equation of the line. Now, to do the equation of a line, I need to look at the up and down slope, right? So I'm taking this line and I'm extending it up. Okay? And I'm taking this and I'm extending it this way. Okay? And this is This is rough estimate math, right? We're trying to find the line best fit, but we're not giving it a formula like we do in statistics. There's an actual formula that you would plug this in, and every point, and it's a long drawn out formula for every single point, and you'll find the exact line of best fit, and you'll find the exact R value. Right now we're just dealing with an estimate. We're estimating, okay? And because we're estimating, make the numbers fit. Make them nice. Okay? Look, it doesn't go through any perfect points, does it? But like I said, these points should pull this up. So if I go from here, right, to here, okay, that's not a bad situation, is it? Right? So now I'm going from this point to this point. And I'm connecting those dots. Now that's still a pretty good best fit line, right? Except now I have two new points. I have 8 and 14. And I have 2 and 22. Okay? And it's these points I'm going to use to create the slope. Now remember, when I'm going from this to this, right, what's the difference in the x? So what's the difference from 2 to 8? 6. What's the difference in y? Now we went positive, right? Positive in that direction. Now when we go from here to here, we're going down, right? So right now I know that this direction is going to be a negative direction. Right? But how much? When I go from 22 to 14. I go from 22 to 14. Here I went from 8 to 2. That was 6. From 22 to 14, how much is that? 8. So this is minus 8. What is slope? Well, slope is equal to the difference in y over the difference in x. So, negative 8 over 6. Can I reduce that? To what? We could do upside down division if you like. 2 goes into there 4 times, 3 times, so it's negative 4/3. Or you can just reduce it in your head. Okay? Alright, but that's my slope. What do I need in order to write the equation of a line? I need mx plus b. I need slope. I need m and b. Right? I need m and b. I have m. What else do I need? B. Yeah. I just need b. Okay? So, find b. Okay? Now we could use point slope, but I've never taught it to you because there's really no reason for it. But you could use it if you knew the formula, right? Or we just use y equals mx plus b, the goddess formula. Y equals mx plus b. That gives us everything. I take a point. It doesn't matter which one. I like 8 and 14. Why do I like 8 and 14? Why does 8 and 14 sound good to me? Well, they're both positive, and they're kind of smaller numbers. 2 and 22, 22 is a big number, right? I'd rather work with smaller numbers if I could. That's all. It doesn't matter. If you like 2 and 22, use it. Okay? So this is x and this is y, right? So y is 14, m is negative 4 over 3, and x is 8 plus b. And so what I have there is 32 negative 32 over 3 plus b is equal to 14. What is 32? Well, I would add the opposite, right? So I'm going to add 32 over 3 here. Okay? But when I add it over here, right? What is 32 over 3? How many times does 3 go into 32? 10 and 2/3. 10 and 2/3. See how I'm doing the same thing? Right? This one, woo, cancels out really nicely, right? But when I'm working with a whole number, I want to change it to a mixed fraction. Improper fraction, beautiful. They go well together. But mixed fractions go with mixed fractions, right? Okay? Because technically that's a mixed fraction. 14 times 1/1. That's a mixed fraction, right? Or in this case, 3/3, which is 1. Doesn't change it. Does that make sense? Blah, 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 blah. All I care about is this. What's 10 plus 14? 24. 24 and 2/3 is B. Okay? I have B, I have M. Y equals mx plus B. Y equals x, and then I just plug in the M. Negative 4/3, and I plug in the B. Plus 24 and 2/3. And before I circle it, I look and see, is that going to be right? Where's 24 and 2/3? Right about here. Where's 0? Right about here. Oh, yeah, that looks about right. Does that make sense? So if it looks right, it probably is right. There you go.
How does that end up as 10 and 2/3? Right.
Oh, how many times does 3 go into 32?
Oh, yeah.
Okay.